Skill Builder and you have this problem on the Skill Builder, I ask you to do this both algebraically and graphically. And so one of them we can just solve using regular algebra, and then the other one we're going to use a graph. So let's start with the algebraically one. So algebraically, this is kind of a tricky one to solve because you got all these squares, you have fractions, which are a total bummer and a half. I prefer to get rid of the fractions if possible, but what I'm going to do first is I'm going to expand that x plus 1 squared. Is everybody okay if I do x squared plus 2x plus 1 for that? And do you know where that came from? Okay. And then just plus 3 equals yucky fraction x plus hideous mixed numeral fraction. I'm going to turn that into an improper. And is everybody okay if I write 5 1/3 as 16 thirds? Yeah, you know where I got that from? Good. All right, now I would really love to get rid of those 3's that are in the denominator because I don't want fractions. Do you remember how I get rid of a 3 that's in the denominator? Good. So I'm going to multiply every single term in this whole entire gigantor thing by 3. And actually, I don't have to write 1 plus 3. I know that's 4, so I'm just going to turn that into a 4. Now I'm going to go through multiply everything by 3. So I have 3x squared plus 6x plus 12 equals, and what's 2/3 when I multiply it by 3? It's 6/3, which is 2. So that's just 2x plus, and then what's 16/3 when I multiply it by 3? I'll give you a hint. It's why we're multiplying by 3. So 16/3 times 3. 16. That's why we did that. We want to get rid of those fractions. Okay, now, does anybody remember when I have a squared term, and plain old x's by themselves, what I have to do in order to solve? Yeah, because I have to make it equal 0. Because the only way, I can't combine a squared term with a plain old x term, so I'm going to have to bring everything from over here over on the right side to the left side. So I'm going to do that by first subtracting 2x, then subtracting 16, because then I get 0. All right, so I'm going to subtract 2x, and I'm going to subtract 16. Okay, so now I have 3x squared plus 4x minus 4 equals 0. All right, now, does anybody remember what I have to do if 3x squared plus 4x minus 4 equals 0? Factor. Very good. So we like to factor using the Xbox method, but if you're listening and you want to factor a different way, then go right ahead and factor a different way. But using the Xbox method, I know that they have to multiply out to be negative 12x squared, and they have to add up to be 4x. So I just think about combinations. Which one of those would multiply out to be negative 12x squared, but add up to be 4x? Okay, 6x and negative 2x. That's not going to be oh yeah, it is going to be positive 4 when I add it. So 6x plus negative 2x is 4x. 6x times negative 2x. Okay. And those are the numbers that go in here. 6x, negative 2x. Okay, now I'm just going to look for the factors by looking at what this side would have to be and what this side would have to be. I know that 3x times x will give me the 3x squared I need. And if I know this side is 3x, how long is this side? 3x times what would give me 6x? 2. There's one of my factors, x plus 2. How about over here? Let's see, I know this side is x, so that means this side is x, and this side is x. How long does that have to be? This is x. How long is that? Negative 2. Good. So there's my other factor, 3x minus 2. So I have 3x minus 2 times x plus 2 equals 0. What do I have to do to each of those factors now to solve for x? Okay, but how do I solve them for x? Oh, good. Set them equal to 0. Good job. So x plus 2 is 0. 3x minus 2 is 0. And now I think everybody knows how to solve for x there. Yeah, negative 2 is one value, and 2/3 is the other. There's my two answers. Real quick, graphically, all I'm going to do graphically to do these is I'm going to graph this. Y equals x plus 1 squared plus 3. So I take out my graphing calculator, I put in y equals, and I type in, what was it, x plus 1 squared plus 3, like that. Okay, and what was the other one? 2/3. So 2/3 x plus, I'll just say 16/3. And now I'm going to hit graph. There's my parabola. There's my line. Do you remember how to find out where they intersect? You can hit second calc, and it's got number 5 is the intersect button. It'll ask you for the first curve. It's on my parabola. I hit enter. It'll ask you for the second curve. It's on my parabola. I hit enter. And then it asks me for a guess. There's 2 of them, so I'm going to have to do this twice. My first guess is there. 2/3 and 5 2/3. The value I'm looking for is the x value. So x equals, 2/3. And then the other one, I'm going to go through that same process. I'll hit second calc. I'm going to pick intersect, and I'm going to arrow over. My first curve is the parabola. Second curve is the line. And now my guess is going to be on the other side. There. That one tells me -2. Using the graph, I could find those points of intersection by using that same idea. And notice how I got exactly the same answers. 2 ways of doing it.